Okay, let's have a quick look at another type of parabola question when we're looking at translation. So this is the type of parabola where its vertex is not at the origin. And this one was actually a past HSC question in 2016, I think. And it's kind of like a band 3-4 level kind of question that you'd expect. So if we look at this, we're given some equation of a parabola, and we're asked to complete the square otherwise and find the focal length of the parabola. And afterwards we want to find the focus. Okay, so the first thing you want to think about is, what do you know about parabolas which aren't centered, or where its vertex isn't at the origin? And what you remember is that there are different forms for that. And one of those forms closely resembles this one. It was x minus h all squared equals to 4a y minus k. How did I know it was this form? Well, if I look closely, I know my x variable is squared and my y variable is actually positive. So over here, I know it resembles this equation for that parabola. Now what do I want to do next? Well, really, I want this form to resemble this one so that I can find the focal length of the parabola. Otherwise, I can't determine what a is if it's not in this form. How do I do that? Well, it actually tells me. I want to complete the square. So all I'm going to do for part A is take my equation of a parabola, x squared minus 4x equals to 12y plus 8. And then, remember, when I complete the square, I'm going to get a perfect square for that quadratic over there. So all I do is I take my single power coefficient and I halve it and then I square it. So half of minus 4 is negative 2. And then I square it. And because I've added to the left-hand side, I wanted to add that to both sides. So I'm going to get negative 2 all squared on the other side as well. And when I expand that out, I'm just going to get 4 equals 12y plus 12. So I've just simplified that out. And then this is exactly what I wanted. I've got x minus 2 all squared equals to 12y plus 12. And remember, I want it in this form over here, 4a y minus k. And you notice that the coefficient of y in this case is actually just 1. So I want that same for me on the right hand side. I want that coefficient of y to be 1. So I can notice that there's a common factor of 12. So I'll take that factor of 12 out. I'll get y plus 1. Now it closely resembles it. The last thing I have to realize is I want to find the focal length. And that's the value of a. In this case, I could just rewrite this side as 4 times 3, y plus 1. So the value of a would just be 3. And that's my focal length. So I know the focal length of the parabola now. But how do we answer part B? I want to find the coordinates of the focus. And for this one, potentially you might want to draw this out just to visualize what's actually going on. But you know that the vertex of your parabola now will occur at 2, negative 1, using these coordinates here. Just be careful with the negative here. If you've got y plus 1, that must mean k will have a value of negative 1. And so if I go to my graph over here, I've got 2 and then negative 1. I know that's the coordinates of my vertex. Remember, what kind of parabola do we actually have here? I've got a concave up parabola. So I know it's going to resemble this shape. So now that I've got both the vertex and the focal length, it's really easy to find the focus. Because you know the focal length is just how far away the focus is from the vertex. And because we've got a concave up parabola, my focus is going to be 3 units above this vertex here. So up from negative 1, I go up, I get to 0, and 1, and then 2. So counting 3 units up from the vertex, I'll go up 1, 2, 3. That brings me to here. And so the x coordinate is going to stay the same because the focus is directly above the vertex. That's just going to be 2. That was my x coordinate. And my y coordinate, well, that was 3 above negative 1, and so that's just 2. So my focus, has coordinates 2, 2. That's what you're going to do.